we got two what we call control path moves. Now, some of the robots support more, and that would be something that you would have to deal with a robot that you in. It's just like we look at four different types of jogs. Some of the robots support a fifth one, which they call a circular jog. But what it does is when you jog Y, the robot spins instead of moving in a straight line. So, but those would be unique to certain robots. So what we're trying to do in this class, of course, is to show y'all what's unique about what are common to all these different robots. So what you would do if you got out and got a job, you know how to do this, and then you would have to figure out what else is added with the robot that you got, right? Does all that make sense? All of them support at least 3 move instructions. Now, when we're talking about move instructions, we're not talking about jogging, right? We're talking about writing programs. Does everybody understand that? And I've seen on the test that some of y'all don't understand the difference between jogging the robot and a move instruction. So when we jog the robot, we're manually moving the robot to position that end of arm tool, right? But we manually jog the robot to a point, and then we do what we call teach the point. And when we teach a point, that is not jogging, that's what? That's programming. When we teach a point, we specify, of course, what type of move we're going to use. And what are the 3 primary types of moves? Yeah, let's see. We have one uncontrolled path move, and that's what we call a joint move. While we need uncontrolled path, there's no guarantee what path the robot's going to follow. First of all, the robot does not follow the path that you jog, right? You understand? You have to tell it how to do it. And then there's there's some components. We're going to have a point number, and then we're going to have a speed in percentage, and then we're going to have a round off. And this is a uncontrolled path move. So the robot's going to move in an arc, it's going to move in an S, it's not going to follow a straight line between the previously top point. Then you have a linear move, which I've already used. We'll have a point number. We'll have a speed in unit over time. And usually this is going to be millimeters per second, right? Or if you're on the KUKA, it's meters per second. And then we'll have a round off. And what is round off? Huh? Well, it's going to hit a point. But you're right, it's going to change the path. And then the last one we have, so linear moves are straight line moves. And then we have what we call circular moves. And then circular moves are going to consist of 3 points. And we call it a circular move, right? But it's not really truly a circular move. It's actually a move in an arc. And it's going to require 3 points. We're going to have a start point, an intermediate point, and then we're going to have an end point. So you're going to have to teach 3 points to do a circular move. Everybody understand that? Now, the robots, and so we're going to come in here somehow. So let's say we're coming in from over here. And we come into the circumference of the arc, which would be the line that moves across the outside, right? Everybody understand that? The circumference. So an arc has a radius, and as the radius moves, it's going to draw a line. This line that's moving in the arc is called the circumference, the outside of the arc or the circle, right? Everybody okay there? And from the center point, it will always be the same distance from the center point. So when we come into the circumference of the arc, which would be right here, this is where things start changing a little bit between our robots. We know we're going to have to teach 3 points. But how do you teach point 1? So we're going to call this point 1. Of course, it could be anything, right? You understand? It could be point 15, but just for a point 2 and point 3. So point 1 on the robots, except for the Motorman, is actually this move between here and here. So this might be a linear move to point 1. And this is going to be true for all the robots. So what we got to do is we got to move from this point to this point. So I'm going to teach this point. This point here is going to be on the circumference of the circuit. Y'all understand? Okay. Now, odds are, I mean, it could be a joint move, but the lab we're going to do is going to be a linear move. And then we're going to hit this point right here. Now, on the FANUC and the KUKA and the ABB, what we would do is then we would do a circular move. We would specify a circular move. And then we would teach 2 points. So we'd probably teach a point here, which would be the intermediate point. And then it's automatically going to pop down and ask me for what? Another point, which will be the end point. Now, on the Motorman, you're going to put 3 consecutive circular instructions. So once you get here with a linear move, then you're going to teach a circular move for point 1. And then you're going to do another circular move, and you're going to teach what? Point 2. And then you're going to do another circular move, and you're going to teach point 3. That make sense? Yeah, in the program, but notice. Yeah, I don't know what you're asking, Patrick. Yeah, up here we'd have a linear to what? To point 1. And then we don't move the robot. Then you don't move the robot. As soon as you teach point 1, so this would be, we'll have to call this point 0. So we'll come in on point 0. We're going to move over to the circumference, and then you're going to teach this guy right here. Okay, using a what? A linear move. Then what you'll do is you'll teach a circular move. When you go to the inform list and it pops these commands up there, one of your commands is for a circular move. Well, what you're going to do is you're going to teach what? You're going to teach point. So circular is going to be the same spot that was point 1. So you're going to teach 2 points on top of each other. Okay, and it'll take how many circular instructions? It'll take 3. Now, if you're doing this on the FANUC, or you'll do this on the FANUC or the ABB, what you would do is you'd do a linear to point 1, and then you do a circular to point 2, and then it's going to ask you to teach point 3. So we're still using 3 points, but on the other robots, the first point is going to be the point 1 of the circle. Does that make sense? And this is on all the robots except for the Motorman. So the Motorman, you'll teach circular point 1 is going to be the one you're sitting at. And how did you get there? With a linear move. And then you teach 3 additional circular moves, which will get you around the arc. Now, what we're trying to do is we're going to try to do a circle. My circle's crummy, but we're going to try to do a circle. So this would be we'll call this point 4, and then around back here to point 5. Well, what you would do on the KUKA is, on the on the Motorman, is you'd just continue on. You'd do a circular to point 4 and a circular to point 5. So there's your 1, 2, 3, 4, 5, 6 moves, but your first one is going to be a what? A linear. Over here, you would just continue on the same way. You do point 4, and then you do point 5. So a circular move on the other robots will take 5 instructions. Well, it's not really 5, because these are considered to be what? These are considered to be 1. On the Motorman, it'll take 6 instructions to do a circle. 5 circular moves, and then 1 linear move to get in there. So this is the work cell. And I can't remember which job it is. I need to probably have 5. It's like we're out of luck. Slab 5 don't have anything in it. And I did these at home. Let's see what it looks like. No, I'm not going to be able to show y'all this. I don't think I've didn't copy. I can show you all the jobs that you're working on now. So this is the job on the Motorman robot. And what we're supposed to do, we're supposed to come down to like 100 millimeters, then down to 15, and then down to 5, which some of y'all didn't. Messed up right there. I'm going to slow this down. The simulation runs a little faster than the robot actually runs. So this is the way we single step this. We would come over here and just highlight on the teach pendant, and we just come down. So this would be 100 millimeters. This should have been a 15, and then I'll zoom in for you. And then it should have came down to what? 5. And then we go to this point, this point, this point. Oops, no, that's the wrong one. This is the one. So the first thing when we start So here's our parts of the instruction, right? We got move, and this on the MotoMan, they call their point C. So this would be what they call 0.0. This would be the speed, and then this would be the round off. So on the MotoMan, they call their round off a position level, and you got choices between 1 and 0 and 7. If you choose 7, it's going to hit the point. If you choose 0, it's going to hit the point and stop. If you choose 7, then it's going to round it off, right? If you choose any number above 0, it will round at a different percentage. So here's our start position y'all should use, and this would be the 100 millimeter, 15 millimeter. This would be 5 millimeters. Then we come around, then we should come back up. This is still not the right one, guys. This is so y'all should have stopped right here. I'm sorry, 5 here, and here, and then what you could do, then you come up to 5 to 15, then to 100. What you're going to do on the next tab, where you're going to learn how to insert lines, you'll come up here and you'll add this point right here, and you'll move up to 15, and then back up to 100, and so for some reason, what I need to do here is, and I can reteach the point, so we're not going to do that. But we can come up here and we can run it. So what's neat about simulation is you can teach your program. If you collide, we can set up what we call collision detection, which means if you collide, you can set your points, you can look at distances. So what you can do on this is really, really neat. What we can do is we can do something called OPL. So if I wanted to go to this corner right here, then I can come over here and just touch. And my tool center point set wrong. Sorry. So undoubtedly my copies didn't work right. To jog the robot, we can come over here and jog it just like you would do with a regular robot. Except here they don't call it. Here they don't call it. They don't call it whirl. They call it link. I'm sorry, they don't call it joint. They call it link. Here they call it rectangular. So here would be Z. For some reason, the tool center point is set right there. This shows you what the tool center point is set. You'll see the arrows right there. So I can't show you my circular move. I'll have to go and see. So this is before next flash on out there. I'll make sure it gets uploaded right. Like I said, I did all this at home, and this shows you the world axis down here, by the way. So this shows you the directions if you're using World Jog. This will show you the direction if you're using Tool Jog, which is really, really neat. But the problem is that the tool center point's not right. Oops. So the tool center point should be pretty close to there, right? It's not. It's supposed to be 208 is what it's supposed to be. Okay. And then if we use something called OPL, what we can do is we can just come over here and point to it, and it goes to that point. Isn't that neat? So we're sending it to the vertex. And then what we can do is we can look at the position. and then I could record this guy right here, Z, and then I could go up. If I needed 15 millimeters, what could I do? I could just subtract from this and go up to 185. Oops. Go up to 185, and that would be 15 mil. That would be, what was it originally? Let me look. Yeah, I could go up to 175, and that would be 15, right? Does that make sense? Yeah, we're not single stepping. What we're doing is we're moving in increments. So this is another way on this robot that we can jog it. But here, we're jogging it Cartesian, but this is showing us the actual location inside our Cartesian system. So if I come over here and touch this point right here, then what it does is this shows me the actual height of that move in a Cartesian system. And if I wanted to go up, 15 spots, then all I have to do is subtract 15 from this, right? You understand? And then I would just do what? I would just move it up that amount, and then that would be exactly 15. But what you got to do is you have to make your model. You have to make this model perfect. So you'd get your model or whatever you're doing, and you would measure it, right? You understand? You might measure it with a set of micrometers, which are extremely accurate measurement devices, and you would go in and you would measure all the dimensions of your workpiece. And then what you would do is you would create a model. So this is a created model. The model for the robot, you import that. It's an animated model. So what you do is when you build a work cell is you say add a robot, and then it brings up the list of robots that MotoMan makes. Then you go in and you choose that robot, and then it pops that robot into your work cell. And then you got a teach pendant that you do what? You jog it, you teach points, you do everything else exactly the same as you would do. Create a program almost the same. It's a little different, but almost the same. And then you teach your program around that model. Then what you can do is you can take this program and go over there and upload it into the robot, and the robot will run it. Or you can take a program off the robot, you can download it, and you can come in here and you can modify the program, and then you can upload it and do things to it that way. This is a model. We don't know that gripper over there. So what do we have to do? We got over there, and we got to measure that gripper and get all those things exactly right, and then we build that model. There's no model for that marker that we use over there. So what do you have to do? You have to build a model. So what you'll do in that class is you'll learn a little bit about 3D modeling, actually make some models. They're not really complicated, and you can see we have a model of the work cell over there. So if you're in the simulation class, and so if you went to work in Mercedes and you program their robots, this is the way they program their robots. They start off programming using simulation, because that way the robots are not offline, and y'all got a little feel on how long it takes to get these programs and to get them right. Well, if you think about it, if Mercedes has over 3,000 robots down there, and they don't have 3,000 people programming robots. So if they was to have to take that line, if they was to have to go offline while they program the robots, it would take probably a year to do that. But they go ahead and they're probably writing programs right now for next year's models. So, but they don't do it on the robots. They do it on what? They simulate it. And then they're down, the guy that came in from Mercedes last week said they're down about a week to go from the old programs over to the new programs. And then they're back up, but they're not in production. They're running scrap cars. He said they usually end up scrapping about 300 cars while they're getting the line ready for this year model. And then after that, they're selling cars. So that's what they go through. In the old days, what they did is they had two lines because everything was hardwired. And what they'd be doing is they'd be running one year's models, and they would be rewiring the other line for next year's models. They don't do that now. They use the same lines all the time. and they run 5 cars down there. They run 5 model cars down there on 2 lines. Well, how can they do that? Well, they just swap the programs out on the robot, right? You understand? Bring in the material for this car, swap the programs out. They could do it on the fly. You know, I mean, you never even see it. So they can run one chassis of one model and do what? The next chassis could be a completely different model. And so they can do that now. So they run 5 model cars. Used to run 6, but they run 5 models. And they're going to add another model, so they'll be back up to 6 models down on those 2 lines before long. But I'm sorry this didn't work out, guys. Like I said, I'll show you what I decided to do is be able to show y'all all these programs. Okay. I think I do have the program where we modify it. So one of the things you're going to do when you modify the program is you're going to add a point. So right now you're doing what? A, B, C, and D. And then what you're going to do is you're going to add another line that does what? Moves back over to A, and then you're going to reteach those staging points. So right now your staging points are over here at D, and you're going to have to reteach them above A, right? So this is one of the first modifications that you're going to make. Okay. And then the next modification you'll make to the program is you're going to reteach some points. I think what you do is you reteach. So let's step it through first. So all you do to step on the simulation is you just put it over here. Okay, so now it's, instead of being 100, it's up to 200. And then we come down, and then we come around, and then we come up to 100 and back. So what we do is we take that first staging area, instead of being 100, we teach it as what? 200. Then the next modification you'll make to the program is which will be C. I can't remember what it is you're going to come up and you're going to change the speed of all the moves. So what you'll do is you'll come back and you'll actually change the speed of all the moves. So now notice it's going around the box faster. So that's the third modification you'll make. You'll change all the linear moves up to 250 millimeters per second. Now this is on the lab, and it's going to tell you how to do it. Some of y'all are already okay with this because even when you was writing your programs, y'all had to go back and modify some of these lines already. Then I think the next thing we're going to do is we're going to delete that 200 millimeter move and move it back to 100. In fact, that was it, I think. So what we're going to end up doing is what you're going to learn how to do, of course, is insert lines. You're going to learn how to modify points. You're going to have to play around with the program, and we're going to call that editing the program. And that's about all you do with a program is you do what? You delete lines. You do what else? Insert lines, and you modify lines. And that's about all you can do with a program. So y'all got any questions on that? So that'll be the second lab. The first lab we'll do is we'll figure out how to copy a program, which we're going to try to do for the ABB. You might have found it, yeah. Okay. We'll give it a shot and see if it works. I got busy with the manufacturing line over there, and I forgot to look it up, Tim. I came over here and just started it with the classes started. So first thing we're going to do is we're going to copy a program. Then we're going to rename a program. We're going to delete a program. And that's about all the stuff you need to know how to do with programs, right? Then what we're going to do is we're going to take one of the programs, this program that you wrote, and we're going to do what? We're going to insert lines, we're going to delete lines, and we're going to modify lines. Now, those are the 3 things you'll do on those 2 labs. So one of them is just learning how to make copies of programs and delete programs and rename them. And then after that, the next one is going to be the circular move lab, where y'all learn how to make it do a circle, and then we'll look at. I'm sorry. The next one is we're going to do is make it follow a we're going to play around with the position levels and make it, let me bring up the lab if I can get over here. So we're not going to do the circular next. All we're going to do is see how we cut corners. In fact, we'll probably do that one before. No, it is circular. So we'll do a circular move, and this is the pattern that you're going to follow. So what you're going to do is we're going to take the box out, and this will be the pattern you're going to follow. So what we'll do, I'll print this off for you, and what you'll do, you'll tape it out there on the floor of your work cell. And now we're going to be working with that hard surface. We're not going to be working with the box anymore, right? So be really, really careful with your jog so you don't collide this robot. We still have a little protection with that tool out there. The tools are plastic or they have a plastic cap on them. But, you know, collisions in robotics is not an option, right? You understand? So this is what we're going to do. We're going to approach point A. We'll come in with a couple of joint moves. Two staging is usually what we want you to do. And then we'll move down to point A. I forgot the height, but it's pretty close. And then we'll do what? Then we'll move over to the circumference. Then we'll come around. And then we'll continue on. And then what we'll do is we'll come back up. We'll come over here, set it back down, and do B. And that's the way you would do that. That makes sense? So all you'll do when you do this lab, when I give you the lab, is I'll print this off for you. You'll get you some masking tape. You'll measure off and put it inside the work cell what it's supposed to do. Okay. And we'll see what happens, and we'll play around with this because what will probably happen on some robots is it'll actually stop at the midpoint, and then it'll continue on. So what you'll have to do is you'll have to, if it stops, it's no problem. Then we'll come back and we'll modify the program and just change the round off a little on those points to make it do what? Make it move nice and smooth. And then the next lab, you see, some of y'all are not gonna, y'all are way behind the labs. And this is another lab what we'll do is we'll just play around with cutting the corners. And I have all these labs. Like I said, I'll show y'all there at home. I'll have to upload them again to see what happens. This is not what I want to show you. I don't want to show y'all the lab. Now what we're going to do next week, probably on Tuesday or Thursday, is we're going to do a class lab. So on this one, what we'll do is we'll start off by coming down. We'll just do a rectangle. And then what you'll do is you'll come back and play around with the round off here to make it do follow these curves. And you know, people think that since we only have 3 moves, how do we do this kind of stuff? Well, we do this kind of stuff by using that round off. And then hopefully, if y'all get this far, the next one is this guy right here. So what we do is we make it follow that line right there. But we only got 3 moves, right? But between circular moves and linear moves and joint moves and round offs, you can make this robot follow any path you want it to follow. You strictly can. So this will be, hopefully y'all get that far. And the next one, of course, is writing a program that writes your name. I don't know if this will be the first class that's never got to it. Hopefully y'all can move ahead a little further. And then the next one, you actually write a program to write your name. And what I'll do is I'll print your name off on a couple of pieces of paper, and then you just write your name. It's really, really, people like that one, but if they get that far. And this right here is impressive to get it to do this, you know. And that's about all the time we have. We do extend this in the industrial robotics class. So the industrial robotics class deals with a lot. It deals with more advanced programming, like doing subroutines and jump instructions and and actually making the program respond to inputs, like stop until you wait on an input, right, and that kind of stuff. We also get into interfacing or networking the robots together so they can communicate, so the controllers can actually communicate with each other. You see all those robots, down at Mercedes. You got maybe 6 robots on a production line, and they all got a job to do, but they can't do they can't run into each other. So those controllers are constantly communicating with each other to make sure those robots are not going to collide, and make sure they all come into action at the same time. So we'll look at how to interface them. And of course, another thing we do is we teach basic maintenance on them too, like lubrication and stuff like that. So okay. So maybe I'll get to writing y'all's name. I don't know, but we'll just see how it works. And like I said, I'll upload those in the next class. We'll show y'all all these different programs. Except following that crooked line, I can't figure out how to draw the line in the simulation. Maybe I'll do that before the end of the class. It was a challenge. Okay, guys, what are we gonna do? Let's go to lab.